Hello, so let's do some analysis for this FET, that is field effect transistor. So we've seen that if we apply positive with respect to the body is tied to the negative terminal. What we see here with this positive voltage at the gate will deposit the positive charges on top of the gate, which is on top of the metal. So if this positive voltage on the gate is sufficient enough, then it will attract electrons from the p type of body that will come at the gate oxide and the p type semiconductor interface. So the interface is right over here. So what you have created an electric field, and there is electric force that is being applied from positive charges to the negative charges, a Coulomb's law. Now if you apply the positive to the drain pin of the transistor and the source is tied to the ground or the negative, so remember the p-type body and the source is at the same potential, which is negative potential. So what you see here, the n-type semiconductor right here, n plus regions at both the ends, that is drain and the source, they are flooded with the electrons, and in the channel you have lot many electrons right here. So because of that, you see now the electrons have a complete path from source to the drain. The channel is complete. We see that the electrons are traveling and the circuit is closed. In other words, the conventional current flows from drain to source. It is called as IDS. It is called as IDS. So on the other hand, when you have such condition, what about the diode conditions? Let's have a look at the diode. So this is a p-type semiconductor and this is n-type of semiconductor. So the n is connected to the negative and the p is connected to the negative. So this diode has a less possibility of getting forward bias. It will not get forward bias, which is advantageous. Similarly, this is connected to the positive right here, and the anode of this diode is connected to the negative. So this is completely a reverse bias diode. So the junction diodes are not getting forward bias. So one of them is clearly a reverse bias, and with the positive voltage at the gate, you have current flow and the circuit is complete when you apply positive to the gate and positive to the drain, and the source and the body are tied to the negative terminal. What if you have the positive terminal at the gate that deposits lot many positive charges on top of the metal, and because of that you have lot many electrons that get accumulated near the surface or interface of gate oxide and the p-type semiconductor material. So you have again an electric field that we can see right here. The body is tied to ground because the gate is positive with respect to body. Now what if, as opposed to previous situation, we apply negative potential to the drain and the source is tied to the positive terminal? So in such case, what do you see? The current direction. Will there be a conduction? Yes, there is a conduction because the channel is inverted with lot many electrons, and n plus regions on either side of the transistor are with so many electrons already. So this channel is complete with the electrons will travel from the drain towards the source, and the direction of conventional current flow would be from source to the drain. So in this case you can write your IDS flows from source to drain. So it is a symmetrical condition, symmetric device. Either pins of the transistor can be used as a source and the drain. In other words, source and drain terminals of FET are interchangeable. What about the diode conditions? So you have one junction diode right here. So the n type is which is cathode, is tied to positive terminal and P is tied to the negative terminal. So this is clearly a reverse bias condition of the diode. Similarly, this diode, you see that the N plus is tied to negative and the body is tied to negative. So this diode is also not getting forward bias. So clearly that's a situation which is favorable, because if these one of these diodes or both, they get forward bias, there will be a current through the junctions of this which will interfere with the operation of the transistor, which is FET. Now we have seen two situations. Now situation number 3, let's say you apply a negative potential to the gate and the body is tied to the positive potential, so it's just opposite polarity. With that, you have lot many negative charge carriers on top of the metal, on top of the gate, and because of that you are going to attract lot many positive charge carriers at the gate oxide and the p-type semiconductor interface. Interface is this line. So you have again an electric field created with the direction of electric field lines and electrostatic force as shown. What about your will the current flow and how? You apply positive here and you apply negative here, but you see now you are having the N plus region on either ends of the transistor, which are lot many electrons, but in the middle the channel is with so many holes, that is the positive charge carriers. So there is no way you can have the current from source to drain or drain to source. On the other hand, you look at the diodes that you can see now, the P is tied to the positive terminal and N is tied to the negative. So this diode conducts with the forward current direction as shown. Similarly, this diode, you see positive is tied to the N plus, the anode of the transistor is connected to the positive and the cathode of the transistor is connected to the positive again. So this is not going to be forward bias, but in this situation there will be a no current that will flow through the transistor. So even if you reverse the polarity of source and drain, there is no possibility that the transistor will conduct the current. Just now the junction are getting forward bias. So we've seen that 4 conditions where gate is positive with respect to body, gate is negative with respect to body, drain is positive with respect to source, and source is positive with respect to drain. So this all biasing conditions helps us to understand the current flow and switchability action of the FET. So hope you enjoyed this video. If you like it, share it with others and subscribe to the channel.